Now let's talk about subtracting integers. We've talked about adding integers and the process of just adding them like you learn to add numbers. Now keep in mind that we have whole numbers. We actually have natural numbers first, and then we have whole numbers. We move on to integers and then rational numbers. So those are different categories or class. When we look at the classification of real numbers. And so when we talk about integers, they include all whole numbers and all natural numbers. Natural numbers would be numbers that we use for things like a person's age, right? 1, 2, 3, 4, 5. Nobody can say that they are negative 25 years old, right? Nobody does that, and that's because that's not valid. So natural numbers are numbers from 1 to infinity. Whole numbers start from 0, 1, 2, 3, and then integers are like 1, 2, 3, 4, but also negative 1, 2, 3, negative 2, negative 3, negative 4. And they include 0. So all the negative numbers, positive numbers, and 0. Notice that I did not list any numbers that were in the form of a fraction. So integers are numbers like 1, 2, 3, and negative 1, 2, 3. Those are just a few examples. In 2.3 from Redwood's pre-algebra textbook, they discuss subtracting integers. They show you the number line approach. Something to keep in mind there is you have a situation, for example, like 7 minus 4. And you could think of it like, let's say you had 8 here. Let's say these all led to 8 units. And I asked you, what is 8 minus 4, right? So you have 1, 2, 3, 4, 5, 6, 7, and then an 8. So you basically think of it this way. You have 1 unit, 2 units, 3 units, 4 units, right? So if you remove 4 units, you're left with 4 units, right? So 8 minus 4 is 4. Again, the number line approach is not typically used for certain addition subtraction problems, but it's just good to understand how the number line is used in this section, and you can do a few practice problems at the end of the section where they ask you to use a number line. In the examples they show you using the number line, but I would say it's more applicable maybe in the word problem section, but I'm actually going to have you stop at number 49 for this section. So you can use the number line if you want. In the practice, they do not ask you to do that, but it's in the you try it section. So when you look at your textbook, you have a section where it says you try it, and in the you try it section, they show you an example and then they ask you to try it. And so you can try using that if you want, using the technique of, the number line, or just doing it mathematically or arithmetically, I should say. So the section starts out by talking about subtraction. Subtraction means add the opposite, or that is, if A and B are any integers, then they give you this example or this set of letters here. If A minus B is written like this, then it's basically you're adding the negative of B to A, right? That's a technical definition there of subtraction. Let's look at some examples here with subtraction of or situations where you have like negative 5 minus negative 6. When you have a situation like this, you can rewrite that as negative 5 plus 6, which is actually the same thing as 6 minus 5, by the way. In mathematics, whenever you're given a chance to add, you have to put two numbers together, and the bigger number is positive, you can use the commutative property of addition to take that number, like in this case, this 6, and move it over to the front of the problem. Why? Because then it just becomes like a simple subtraction problem. It's no longer looking strange where you have like negative 10 plus 20. You could just say 20 minus 10, and that works out, better for many people. So let's remember that we can just move the number as long as we're consistent in taking the sign that it goes with that number. You can move it around with the commutative property of addition. Again, in this case, these two numbers are adding, and we're just moving that 6 over to the front. So they give you an example, they define subtraction, they show you the number line, and then they talk about order of operations, or using the order of operations principle for doing some of these problems. When you're dealing with order of operations, remember that PEMDAS is parentheses, exponents, multiplication, division, and then addition, subtraction. But for the addition, subtraction, you're going from left to right. So you're going from left to right, and you just keep that order consistent. You go from left to right, and when you apply that principle here, it's important to note that if you have a problem like negative 3 minus 4 plus 11, you just go from left to right. So you do the negative 3 minus 4, right? That becomes negative 7. And then plus 11, and that is the same as 11 minus 7, by the way. So that answer is actually 4. So notice from left to right, we can work out the problem. It's important to remember PEMDAS applies, of course, in addition, subtraction, multiplication, division. But for multiplication and division, the order in which you do them is from left to right. They both rank in the same level. So parentheses and exponents rank higher than multiplication, division, which are actually equal in a sense, and the one that wins is usually the one that occurs first when you're going from left to right. And then addition and subtraction, you also go from left to right. So that's how you do, that's how we use PEMDAS for some of these problems. So there's a lot of practice problems here for you. There's real life applications here when we talk about the temperature change, right? Some people might live in places where it's always warm, so they might not know about this. But if you live in northern Minnesota or Wisconsin or North Dakota, you know a lot about negative temperatures. And so when the temperature goes from negative 44 degrees to positive 44 degrees, that's a huge change, right? And that's where this integer application can be seen, is even with temperature discussions. And so that's what we 2.3 discusses, is just adding and subtracting integers. Let me give you a few more examples here. If you have a situation like, let's look at 7 plus negative 16. If you have a situation like this, it's important that you know that only one sign is going to win. And it's, in this case, in math, the negative wins sometimes. In life, we know that positive is going to win at the end of the day. But in math, negative does win once in a while. So 7 plus negative 16 will become 7 minus 16. And that, of course, would be, if you think of it this way, it's almost like saying, what is 16 minus 7? But then what's the negative of that? So that'll be negative 9. So think of it as, so 7 minus 16. So you have $7, but you want to buy something that is $16. Well, you're going to owe $9 if you end up doing it the way that you're doing it with the $7 you have. Let's look at another example. Negative 20 minus 10 minus 5. So the negative 20 minus 10 is negative 30, and then minus 5 will give us negative 35. So that's another example. Let's look at another one. 5 minus negative 10 minus negative 10. So it becomes 5 plus 10, and then notice that these two negatives again meet and they become a plus 10 again. A negative times a negative is a positive. So 5 plus 10 plus 10, and that actually gives us 25. So that's how we get the answer to that problem. And let's look at another example that is a little different. If you have 2 minus, and then in parentheses, minus 3 minus 5. If you have a situation like this, then it's 2 minus and then into negative 8. So now you have 2 minus and then negative 8, which becomes 2 plus 8, which is 10. So 2 plus 8 is 10. But notice we first took care of the parentheses over here. You take care of what's in the parentheses, and then it can interact with the negative that is waiting outside. Those two negatives would meet. It becomes 2 plus 8 is equal to 10. So that's what 2.3 deals with, and we will see you in the next video.